Hello. So, any sufficiently advanced technology is indistinguishable from magic. Therefore, a complex technology behind games makes our game engine programmers wizards. And if pop culture teaches us anything about wizards, they are extremely hard to manage. Today, I will tell you a bit about the discipline called technology production. What it is and what challenges do we face, and what tools do we have to overcome those challenges. My name is Kleszczyński, and I work in Techland as a technology producer, a developer behind Dying Light franchise. I've been working in Techland close to 4 years now, and I help with releasing of Dying Light 2, Bloody Ties DLC, and now with Dying Light The Beast. And before I joined Techland, I spent 9 years in smaller companies and started as a gameplay programmer actually, and moved to producer role 3 years before joining Techland. As a former programmer, I was always close to technology, and I dedicated most of my production time to managing technology teams. So in Techland, we have technology, and it's about 80 programmers divided into 12 teams. And our clients are games, obviously, but also publishing and department called user-generated content. And they all have very different needs and very different priorities, and we need to satisfy them all. So a bit more about technology department itself. In general, is a service team creating the game engine for one or more games. And we usually are involved in a direct support of production, and we don't produce only engine. It's also live ops, DevOps, and most importantly, tools. And technology production is a managerial group that is focused on smooth and efficient delivery of those products. So we face 3 main challenges. The first one is that we work with multiple clients. Although we are one company, there is a huge client list. And those clients have different priorities, I mentioned, and they often change requirements during the production. We also need to be swift and create this technology fast, because that's our advantage over having a commercially available engine, that we can respond quickly and satisfy the need exactly. But we need to be stable, so there is a limit of speed. Because if we create an unstable technology, then we derail whole production in the whole company. And the third one is to be transparent about the deliveries. People will change requirements and priorities, so our schedules will change, and other people need to know about this. So let's see how the tools we have can support us with overcoming those challenges. So it's just a selection of tools, one that I find most useful. And I will start with technology validation process, and then talk a bit about midterm planning, cadence, and rituals that we use. So technology validation process, it's a big topic, so I will divide it into subparts. This brief introduction to what it is, and we will talk a bit about levels of completion, and you will see why in the short time. And then I will show you who is involved in this process and how it works. So technology validation process is a way of managing incoming requests. The goal is to make sure that the requests are useful to the users and they are feasible in terms of our technology. So we don't want to create something that doesn't fit. We also need to make sure that they are well scoped and that we divide them in meaningful iterations. Having these iterations, we can re-evaluate the incoming request, the rest of this request, and we create a predictable environment in which we deliver. It helps with production, but it also helps to manage the expectations of our clients. And by involving the users from the beginning and throughout the whole process, we also assure having a feedback and short iterations that are better suited, that create better suited solutions. So I mentioned level of completion. It will go through all the technology validation process part because that's like our definition of milestone for each feature. You can say these are like the 4 core iterations that we always will do for a given feature. We can do more iterations, but it won't get less than 4. So the first one, L0, would be documenting and prototyping to validate the idea and gather everything that we need to know about the request. Then we go to L1 level, and it's a functional, or you can call MVP. It is a working solution that is directed at a group of people we call power users. So more about power users later. Then L2 is production ready, and by production ready we mean not only being a performant solution, but also being able to use this solution throughout the company, so even junior can jump in and help. And L3 is like an open-ended iteration that is consisting of polish and quality of life improvements, maybe some optimizations, something that is not critical for the release, but it's nice to have, and we will like to add it later as soon as we have time. And the important thing is that during production, we focus only on one LOC at a time. If we identify some requirements that are necessary for the further LOCs that we are the one we are focusing right now, we will make a note and postpone it and focus only on the one. So who will you need to perform this process? First of all, power users. I promise you to talk in depth about them, so here it is now. Usually it's the original requester, as the request, at least in our company, comes from people with in-depth knowledge of the tools that they are using or systems that they are using. And usually they are the highly skilled, most likely senior employees that have a good understanding of that they are working with a technology still in development. And they will focus on the solutions and like major problems, and not will be disturbed by constraints and little bugs. They are very important because they are the ones who will give you feedback on if the solution is what they need, and give you feedback if it's going in the right direction. The second persona is technology owner. It's a dedicated programmer, usually a director or lead. We also use principals and seniors for that function, but less often. This person guides the process. So this is the person responsible to create all the artifacts during the process and to propose solutions to the requirements that we get, but also to propose or point out constraints of our technology that we still need to keep in order to deliver a solution. And if in your company you have a position of pipeline owner, we actually don't, it would be great to include them. If there are not the original requester, of course, because they usually are. So how it works? In a brief, it's you get a creative brief or design document from the contents team, and you create a product requirement document gathering all the requirements and constraints. Then you propose a technical solution laid out in the technical specification document, create a plan, execute it, deliver. Easy, right? Yes. If we zoom in, the steps are a bit more complex. Even leaving out the option that the request is not supported by any creative brief or design doc, which is often, it still involves several decision points. First, we need to decide if the process is really needed. It's a complex, lengthy process, so if the request is small and can be easily satisfied with existing technology and like a 2-week worth of work, it's not feasible to run the whole process. But if we got a bigger request, then we need to act on it and appoint the tech owner. Tech owner then talks to the users, talks to the requesters. Together with the technology producer, they identify the group of stakeholders, the power users, the pipeline owners, everybody who will be affected by the change. And tech owner creates this product requirement document. It's a standard document that you can find definition of on Wikipedia. It's used in many software engineering companies, but it's, I think, rarely used in game development. And after creating this initial PRD, we go to the stakeholders, we go to the power users and have a meeting. In this meeting, we discuss all the requirements, all the constraints that tech owner add, and we identify which level of completion do we need to assign to these requirements. We may split those requirements, and then we leave only the ones for the next level of completion in this document, and the rest is moved to future documents. It may ring a bell if you know the product owner's process of refinement of the Scrum backlog. That's very similar to this. So we have this PRD validated. We know what level of completion, what requirements for a given level of completion we have. Then we can propose a solution. So tech owner, together with a team, create at least one draft of the solution. It may be that the problem is complex and the solution is a bit more risky, let's say. So they create at least 2, maybe 3, and we discuss pros and cons with the users to select the best fit. And having this, we create also a list of deliverables in a form of work breakdown structure, something that you can find in something called PMBOK. So like a corporate way of managing projects. And having this PMBOK and discuss it with the users, we are now in position to say, okay, we know what we want to deliver. So we create a backlog in Jira and we start executing a plan using iterations, using sprints. And when we have anything that is usable for users, so for example, it satisfies a specific scenario, it doesn't need to implement whole feature yet, we get the feedback. And then we iterate. We move to another LLC, we repeat the whole process once again. But this is the point where the feature might be also dropped and maybe aligned to what we find. Maybe we find that the need, it wasn't exactly what we thought and we need to pivot. That's the best point to do so. So this technology validation process covers partially the first challenge of technology production. So we'll see what else supports it in a minute. But we also supported the second challenge with levels of completion, because having these iterations also creates a understanding of what we will deliver when, and it ensures that we deliver as fast as possible. So the second thing would be midterm planning, the next tool. And here comes a story from our production. Like 2 years ago, we made this beautiful roadmap for 1 year, and it was signed off by everybody from our directors to our C-level, and then we start working on it. And we worked really hard for 1 year, and we delivered a lot. And then we sat down, it was around the Christmas party, looked at our roadmap for a year, and we start thinking, what's it gonna look like for the next year? And you know what? It would look the same, because we haven't delivered anything from this roadmap, and we delivered a lot. So it was an example of a long-term planning, and long-term planning tend to be too high level and simply a wishful thinking. During the year, the company changed priorities so many times that we were unable to even keep track of the changes, because we really thought that we are doing those things that we planned, but we are only disturbed by the other stuff. So on the opposite end of the scale would be a short-term planning. This is, however, too much detail. It's good for planning a sprint, but it doesn't give a big picture, and it's hard for higher managers to understand what the teams are really doing. So we settle on midterm planning. It's focused on features and their level of completions mostly, and seems to be realistic so far. But it's subject to change, and it's way easier to change and adjust the midterm plan than it's to adjust the long-term plan. So we present our midterm planning in the form of a block plan, as we call it. It's a living document that is presenting a milestone roadmap. It's a 1999 looking Excel sheet, and it works. Each developer in this document is presented with its own track, and it's showing only high-level topics for a feature or some themes like bug fixing. It's updated frequently, so at least twice a sprint, and we have a 1 month sprint, and presents current state of a plan. And what's most important, it's available to everybody in the company. So this is example of how it looks like. It's really ugly, but yeah, it delivers the message. So before sprint starts, we have something planned. The blocks are corresponding to the estimates of the tasks that are actually doubled to incorporate some buffers. And as you can see, during the sprint, we mark things that are done with green. We mark things that are in progress with yellow. It's a manual labor, and if something changes, we can easily move things around. So this block plan, together with technology validation process, satisfies our need for working with multiple clients, as they now can see what they would expect, and a transparency issue. But it's not all. So if you ever seen an automated production line, I'm sure you've been mesmerized by the rhythmic dance of a machine. And a good flow in work is important not only when delivering a single task, but also when you go to the broader context. And a well-chosen cadence, it enables your teams to deliver as much work as they can. And a well-chosen cadence gives you some breathing room, so you have time to actually work, but it's tight enough to be delivered frequently. So I will show you two different cadences. I will show you our cadence, which you can see now, and I will show you another cadence from Microsoft Visual Studio Code team, just to make visible the point that it's very, very specific for a team. So in Techland, we technology, because it's not like for the games, it's only for technology. We use milestone of 16 weeks, which is divided into four-week sprints. And each sprint is divided into 3 work weeks that we perform business as usual. And the last week is what we call hardening week. It consists of planning and bug fixing and sewing up the work we did in the sprint, so we make sure our work is up to quality. And this kind of sprint is repeated 3 times. And the 4th sprint in a milestone serves a similar purpose to our hardening week in a sprint. So it's a hardening sprint or release sprint where we make sure that all the goals of the milestone that we made in the beginning are met and that are into quality. And here is the other cadence, as I mentioned, Microsoft Visual Studio Code. And they're doing a very similar thing, because although they start with planning, they are bug fixing live bugs during the first week. Then they do 2 to 3 weeks of work, because they are not like week-based, they are calendar month-based. And at the end of the iteration, they bug fix and release the new version. Then the cycle repeats. They identify any critical bugs that are live, fix them, and in the meantime plan for the next sprint. So as you can see, your mileage not may vary, your mileage will vary. And you need to experiment, you need to measure and adjust your cadence to best fit your team's need. And the last tool I want to talk is rituals. So to support this cadence, we have numbers of ritual, and I will start with the actually last week of the previous sprint in this graph. So we end the sprint planning for the next. So that's the next sprint planning ritual in the 4th week of a sprint. And then we, together with leads and director, we prepare a sprint report to showcase to our head of technology, and it's also then converted into bigger report that is sent to other production departments and to our C-level. And this report is prepared in the last week and is presented to the heads in a first week of the next sprint. Then we start working, and we try to not interrupt our programmers with too much meetings, and the next big thing would be in the end of the second week, when we usually do bug triages or sprint backlog groomings, because something changed in the sprint and we need to adjust our block plan. We also have dailies, and that's go without saying. And we also do something we call cross-team things. If we are working on a feature that is needed to have couple different teams working together, then we have this one weekly meeting or bi-weekly meeting to make sure that everybody is on the same page. Usually there are mostly producers in these meetings, but some power like team leads maybe are also there. So with cadence and reports and rituals, we finally overcome all our challenges. And to brush up a bit, what I would like you to get from this presentation is that technology team is a single discipline and service team, and it uses an iterative approach to production, and it consists of mostly of problem solvers, so solution generators. And the tools we use for our production are technology validation process, midterm planning, and right cadence and rituals. And I would argue that the technology validation process is the most important of them all. So thank you.